So now we're ready to start the core objectives of Unit 9, and the first thing we're going to talk about is rewriting expressions, but what expressions are we going to rewrite? All right, let's see what they are. So in a previous unit, we talked a lot about exponentials, which is an equation where the x is in the exponent. We didn't talk about how to solve simple equations like this, 5 equals 2 to the x. What is x going to be to make this equation true? One thing you might have an idea of like dividing by 2, but that's not actually going to cancel out these 2's because it has an exponent of x and we don't know what the value of x is. All right, so that's not going to work. Another thing you might think of is, well, how do we cancel out exponents? We use the opposite of the exponent, so you do something like this. And that fixes it over here, but now we have this 1 over x over here. All right, so pretty much all the methods we've had for solving equations don't work for this seemingly simple equation, right? There's only 3 things in this equation, a 5, a 2, and an x. We have no idea how to solve this. But to solve this, what we need to do is be able to somehow get this x out of the exponent. And how are we going to do that? We're going to have to introduce a new function. All right, so in order to get x by itself, we need to undo the exponential process. All right, and undoing a process is the inverse. All right, so this is the reason we talked about inverses in the previous unit as well, because now we're going to put together Unit 7 and Unit 8. All right, exponentials and inverses combined to give us the inverse of the exponential. All right, so if we have the inverse of the exponential, we can solve this equation. All right, because if we do the inverse over here, it's going to cancel out the exponential part, and then we'll get x. All right, so what is the inverse of the exponential? It's called a logarithm. All right, so logarithm is just the fancy new function we're talking about, but at the core, its definition is that it's the inverse of the exponential function. I remember inverses just do the opposite. So let's look at what it looks like. So if we start with an exponential function, we have a raised to the b power equals c. So again, exponential because there's an exponent in the problem. The logarithm is going to do the opposite. So the first thing is the log is our first function where there's actually like a word that says I'm using this function. So all the other times we've just kind of put an x somewhere and that was our function. To do a log, you actually have to write out I'm doing a log. So I write out I'm doing a log. The log, just like your exponential, your log has a base because it's related to exponential, so it makes sense they both have to have a base, some thing that I'm talking about. And then we know logarithms are the inverses of exponential. So the thing that I put into my exponential, that's my x value. Inverses do the opposite, so now it's going to be the output of my inverse. The thing that I get out of my exponential, that's my y value, that becomes the x value, the input for my logarithm. So if we want to look at the relationship, the bases are the same, but then these two things switch places. And that's all we learned about inverses before, are they just switch the place of the input and output, the x and the y value. All right, so what we're going to focus on in this learning objective is we have logarithms and exponentials. We have these two separate different things, but because they're inverses, we can switch back and forward between them. So in this one, we're just going to focus on switching back and forward between logarithms and exponentials. The only thing you really need to remember is, again, what we just went over on the last slide, the base stays the same. The thing that's in the exponential is outside the log. The thing that's outside the exponential is inside the log, right? It's just switching those x's and y's. All right, so here we go. All right, we have all of these expressions, or these equations that have exponentials, right? Every single one of these has an exponent. I'm going to rewrite it as a logarithm. So the first thing, the base of the exponential is the same as the base of the log. So this one, 2 is the base of the exponential, so I'm going to write log base 2. All right, so I'm going to put that little 2 down there to say this is the inverse of the 2 raised to something function. The thing that was outside the exponential is going to go inside the log. The thing that was inside the exponential goes outside the log. That's the whole process, just knowing you switch where the 3 and the 8 are. But all the other ones are going to be the same. 4 to the negative 2 equals 1 over 16. The base of my exponential is 4, so the base of my log is also 4. Right, so that number just stays the same. But now inside the parentheses, I'm going to put 1 over 16 because that was on the outside of the log. And that's going to be equal to negative 2 because I was inside the exponential, right? So this is my x and this is my y. And then the y here becomes the x there and the y there. Last one, 9 to the 1/2 equals 3. The base of my exponential is 9. All right, 3 is going to go into parentheses because it was on the outside over here, and it's going to be equal to 1/2. All right, so as long as you keep track of what your original x and y is, you flip it. The thing that goes inside the parentheses is your x, so that's your old y. All right, just keep track of where everything's going. All right, so here's one for you to try on your own. 3 to the 4th equals 81. Again, you're going to rewrite it as a logarithm. And here's the answer you should get. Again, there's only 3 things to keep track of. The base stays the same. The thing in the exponent goes to the outside. The thing outside the 81 goes into the parentheses. So just keep track of those 3 things, and you can rewrite your exponential as a log. Now for our next set of examples, we're just going to do the same thing in reverse. Now we start with a log, and we're going to rewrite it as an exponential. But again, same thing. The x's and y's are just going to flip, and the bases are the same. So my base is 2. That's the number there. 16 is inside the log, so it's going to be outside the exponential. 4 is outside the log, so it's going to go into my exponential. So 2 to the 4th equals 16. And we know our rules for exponents, so that equation should also make sense. 2 to the 4th is 16, so that's how you know you did it right. All right, all the other ones the same. Log base 4 of 2 equals 1/2. The base is 4. The exponent I'm going to pick is on the outside of the log. That's going to be 1/2. And it's equal to what was inside the parentheses, 2. And 4 to 1/2 is 2, so I know I did that right. And last example, same thing, base 3. Thing in the parentheses is going to be over here. The thing outside the parentheses is going to go into my exponential. And 3 to the negative 2 is 1/9, so I know I did it right. All right, so same thing, just keeping track of what is where and using the same base. All right, so here's one for you to try on your own. Rewrite this expression as an exponential. And here's the answer you should get. Again, just keeping track of what is where. The base is 4 in red. The thing inside the log, 64, goes to the outside of the exponential, so it's the thing it's equal to. The thing outside the log goes into the exponential, so that becomes the exponent. All right, so for this learning objective, you're going to do a skill check. The skill check is going to have 4 problems. So 2, like the first one you did, rewriting a exponential as a log. And then 2, we do the opposite of that, writing a log as an exponential.